The control plan is used to determine the key characteristic to test during the repeatability study. We have created the inspection project that contains the necessary features, trim edge comparison points, and sequencing. The sequence is built in to the template, and it will be important when we analyze our repeatability study results. We've also created an Excel template for our repeatability study. Once the measurements are complete, we will use ReportLoop to analyze our results in this template. And when everything's prepared, we will upload the inspector project to DataLoop. The operator first searches, then downloads the inspector project from DataLoop. Because a nominal project was created, all he needs to do is create a new piece. The sequence begins with the guiding instructions demonstrating the proper mounting and clamping procedure. Then the tooling balls are probed, and the number of points to probe is defined with guidance. Scanning begins, and our operator follows the feature scanning guidance, measuring until the proper coverage is reached for each object. A boundary scan will be used to measure the trim edges and holes, while a surface scan will be used for the constraining planes and other plane features. The scanning guidance reflects this accordingly. The part is removed from the fixture and replaced in between each of our 10 trials to make sure that the process of mounting the part into the fixture is considered as well. And once all 10 pieces are complete, our operator uploads the project back onto DataLoop, so the data becomes accessible for the tooling engineer. So I've got word from the quality team that all 10 measurements are completed and have been uploaded to DataLoop. So I've logged in and downloaded the project. I can see that all 10 pieces are in the project. So now I'm ready for the repeatability study. I'm going to use the Excel spreadsheet provided by Polyworks to calculate variability. So all I need to do in Excel is connect to Polyworks. And you can see that the current open piece in the inspector is displayed in bold here. So I'm going to prepare this sheet for specifically the counter sinkhole 1 measurement. So if I open my features branch, find counter sinkhole 1. I can, for example, insert the nominal value into my sheet, and I can insert my measured value in here as well. And that's going to be our first of 10 trials used for the repeatability study. Now the link is made between Excel and Inspector for this value, I'm going to be able to add the other links automatically. This ReportLoop tool will add all the links in the application in appropriate cells for all the trials in my Inspector project. This spreadsheet calculates the equipment variation as a percentage of the control's overall tolerance. What we want to see is a value of less than 30% of the tolerance used by the equipment variation. It also displays the values from the project on an IMR chart, or individual moving range chart. And that's about done there. So I can see that the equipment variation makes over 400% of my allowed tolerance. I have more equipment variation than my overall tolerance here. I will need to verify the reasons why. On the IMR chart, there is a value that stands out, trial number 6. The normal value is 6.35, and on the measured here, it's more than 9 mil. So I should probably start by investigating that particular piece in Inspector. So if we go back into Polyworks,